A recent photo featuring the interstellar visitor 3I Atlas has uncovered something remarkably odd. Researchers have found that sunlight interacts with this body in a manner unlike any we've encountered or even conceived previously. Check out this snapshot. It comes from the Mastcom-Z camera aboard NASA's Perseverance rover on the Red Planet. The picture reveals a hazy, indistinct patch in the Martian atmosphere, right where experts anticipated the appearance of the interstellar body 3I Atlas. This marks the inaugural sighting of 3I Atlas from such proximity. In the frame, the comet shows up merely as a subtle blur adjacent to a cluster of stars, each roughly equivalent in faintness to magnitude 8. Additional evidence points to motion in the Martian heavens, which experts attribute to the interstellar guest 3I Atlas itself. Notably, this shot wasn't snapped precisely at its nearest pass to Mars. The Perseverance rover grabbed it a full day prior to that event. Experts note that the true closest encounter would require monitoring from Mars-orbiting spacecraft. Yet, owing to ongoing NASA operational disruptions, it might be a while before those high-resolution proximity shots of the body get published. As 3I Atlas swung by Mars in close proximity, the Perseverance rover detected heightened activity on the planet's surface. The photo captures dust devils twirling near the vehicle and a massive dust cloud brewing along the skyline. The comet's tail doesn't appear in the rover's views. It remained too dim during that period. Researchers have already noted the comet's atypical nature due to the absence of a detectable tail, a trait uncommon among typical comets. That said, nearing Mars, the comet started forming a slender tail, albeit far dimmer and slimmer than precedents. Other shots of 3I Atlas offer greater insights into its form, though they've yet to receive full authentication. Drawing from those preliminary views, the comet presents an extended silhouette, resembling more the initial interstellar body Oumuamua and differing from 2I Borisov. Lately, the interstellar comet 3I/Atlas zipped relatively near Mars on October 3rd, approaching to about 0.19 astronomical units. That's approximately 28 million kilometers distant. It's now hurtling across the cosmos at close to 200,000 miles per hour, en route to its solar perihelion. But developments have shifted abruptly. Stargazers suspect that 3I Atlas endured influence from a coronal mass ejection, a tremendous solar flare spewing energy and material. Following this solar outburst, the comet vanished from sight, probably owing to its growing remoteness and the overwhelming solar brightness. Moreover, Earth is now traveling counter to the comet's path, complicating visibility amid the starry glow. Consequently, 3I Atlas won't re-emerge until later this year. And right as observers deemed it an ordinary comet, fresh sightings have exposed bizarre irregularities in its makeup and light patterns, traits that question our existing knowledge of these entities. Experts have just performed the debut polarimetric studies on the interstellar comet 3I Atlas. As sunlight traverses the void and strikes a body like a comet, the rays don't simply reflect directly. They disperse across various paths. Every minuscule dust mote or icy fragment encircling the comet functions as a tiny reflector, altering light propagation. Upon encountering material, say the debris halo of a comet, these light undulations can align more uniformly. Rather than scattering haphazardly, the oscillations begin to orient along specific axes. This alignment of light oscillations is termed polarization. By gauging the degree of polarization and its orientation, stargazers can glean details about the reflecting particles, their dimensions, contours, textures, whether jagged or sleek, and composition, ice, stone, or hybrids. In comet observations, researchers commonly detect positive polarization at wider phase angles. At narrower ones, numerous comets display negative polarization. For the interstellar comet 3I Atlas, observers recorded an exceptionally intense negative polarization, surpassing that of any prior comet. This came as a major shock. It suggests the surrounding dust particles on 3I Atlas diverge significantly from those in solar system comets. They could be more jagged, asymmetrically shaped, or composed of exotic or unfamiliar substances locally. This represents the initial detection of such patterns in an interstellar body. Although we've examined multiple solar system comets and interstellar arrivals, none have shown the distinctive polarimetric traits observed in 3I Atlas. Its profound negative polarization, dipping to -2.77% at a 6.4 degrees phase angle, stands without parallel among documented comets. This peculiar pattern indicates that 3I Atlas, this interstellar object, might have originated in an entirely distinct setting, perhaps within a different stellar system or right at the fringes of our own solar system, where temperatures plummet and ice dominates. Researchers had earlier proposed that it's even older than the solar system we know. Their findings indicate it probably hailed from the galaxy's core areas, positioning it as one of the oldest and most enigmatic travelers ever spotted drifting into our cosmic vicinity. Adding to the intrigue, experts have spotted an odd chemical makeup encircling this wanderer from beyond. The surroundings of this space intruder closely resemble the atmospheric and surface features of our nearby world, Mars. Such a resemblance points strongly to the idea that it didn't emerge from standard comet birth zones like those in our solar system. Rather, it could have come from a planet's crust, maybe from a realm echoing Mars' harsh environment. Certain observers note that the thing emits an eerie luminescence unlike that of ordinary comets. This could imply that as it draws nearer to the Sun, it might vaporize extensively or even fragment upon reaching its closest solar approach. Moreover, researchers have picked up on additional bizarre actions from this entity. We've seen that 3I Atlas is shedding substance while enveloped in a noticeable vapor haze. Typically, as comets expel gases, the outflow nudges them off their trajectory, akin to miniature rocket bursts. Yet 3I Atlas acts quite otherwise. Despite the gas envelopes building up, its route remains utterly unaltered. A few experts speculate this oddity might account for its vast bulk, since maintaining structural integrity amid gas emissions suggests it's far more compact and weighty than anticipated. Initial calculations pegged 3I Atlas as at least 1,000 times bulkier than prior comets. Fresh analyses now peg its heft at exceeding 33 billion tons, a staggering figure for something born of nature. Beyond its sheer scale, way bigger than the last one, there's simply insufficient solid debris scattered through interstellar voids to hurl such a colossal boulder into our inner solar realm in the last 10 years. How do you figure there's not enough debris? What exactly are you saying? Does that bolster your view that this isn't some ordinary formation? Absolutely, given the sparse supply of solid stuff per cubic volume out in interstellar expanses. Lately, Professor Avi Loeb sorted the peculiar traits of 3I Atlas into two key groups. In the initial group, he included quirks that future observations might clarify. Among them, its dimensions, the peculiar backward tail, a forward-spraying beam of diffused sunlight roughly 10 times its width and aimed sunward, its atypical elemental blend, and its pronounced negative light polarization. In the other group, he slotted the enigmas that could baffle us indefinitely. These encompass how 3I Atlas's path hugs the ecliptic plane, the same disk where planets circle the Sun, deviating by merely 5 degrees. An additional oddity, the intruder's entry timing aligns perfectly for near misses with Mars, Venus, and Jupiter. Even spookier, its incoming vector matches within 9 degrees the famed WOW signal picked up on August 15, 1977, which some once suspected as an alien broadcast. Professor Loeb contends that folks dead set on calling 3I Atlas a run-of-the-mill comet must pony up explanations for all these freaky alignments via strictly cosmic mechanics. That's the wrap for now. Be sure to eye our fresh 3I Atlas Interstellar merch tee. If it catches your fancy, snag one to back the show. Enjoy your day, and cheers for tuning in.